All right, this is, you might want to turn the volume on if you're listening to this because I'm doing it from my desk. So what we're doing today, we're on section 7.1, so chapter 7 is on page 63, so maybe look over pages 63 to 68 to get a little review, but chapter 7 is on
It doesn't seem important.
geometric
On top of each other, so this.
construction.
Right here, this two should have been right here, and three should have been right here.
7th and 8th grade, that volume's not working for me, that's gotta go down. Geometric construction, so geometric just means shapes. A lot of times that has to do with triangles and angles and things like that. Geometry, that's what geometry is. Construction, first of all, I gotta spell construction. Construction means to construct or to make. And primarily what we're gonna be using to do this is a bullseye compass. If you don't have a bullseye compass, then get one from me. So you can see right here, it's got the angle measures on it. And you can also see that this moves. Mine's not moving because I put a piece of tape on it. You're gonna need to get one of those at some point. I'll show you what you need to do with it. But 7.1 is constructing angle bisectors. So if you look on page 69, it talks about angle bisect. So if you have an angle by the prefix bi, what does that mean?
I feel like that's just.
Think bicycle.
That looks so much.
If you have a unicycle, it has one wheel. If you have a bicycle, it has two wheels. So bi just means two. So if you have something that is bisecting an angle, what do you think that means? It's cutting it in half or two equal parts. So let's say that the measure of this angle before, so let's say this is ABC. Let's see, ABC is, let's say that's 40 degrees, and this is D. If BD is a bisector, that means that ABD and measure of DBC is what? So if I tell you BD is a bisector, then ABD and DBC, this is supposed to be a D. What's the measure of both of them? If it's a bisector, it's cutting them into two equal parts.
We don't know what the whole thing is. So
Yeah, we do. It says right here, this is 40 degrees.
20.
Yeah, so each of them would be 20 degrees then. So that's big. The big thing you need to know about bisectors is if it is a bisector, then it cuts it in half so that they're two equal part degrees. So if you look over at, okay, well they're showing you stuff on top of page 71, you don't need that. Bottom of page 71, you kind of are going to need. So actually, you're gonna go bottom of page 71. So what we're doing now is constructing an angle bisect. Construct angle bisector. So let's say we have that same angle that they have. You can make something about equal to it. Make sure that you're making it plenty big, because you're going to want something bigger is going to be easier for you than something smaller here. So let's say this is A, B, C. So what you can do with this, your friend, the angle bisector, number one, you're going to want to get a piece of tape so that you want the piece of tape so that it goes across right here, so that when you stick this in here, and you'll see why you need that, this doesn't move back and forth, because this will move back and forth really easily unless you tape the back of it. So get a piece of tape and put it on the back of your bullseye compass. That's what they're called, bullseye compass. Looks like a bullseye.
Is that how it
You wanna put it right on the back, make sure it's not covering up either this or this.
Where's the center?
I look up on the board. Make sure it's not covering either of those holes, cause that's where you're gonna put your pencil in. Put your pencil in right here, or your pencil in right there. But the other part, you want it to cover, you want the tape to cover that so that this is not moving back and forth. So, you flip over to page 72, and they're showing it a little bit differently, so I'm doing it a little differently here. Basically, you wanna be able to put this on the center, so you can kinda see, hey, look, that's right at the center. And you want to be able to move this, I have to remove the tape a little bit, or maybe all the way, so that it can go like this and go into go across both parts of the line. So I move it where I want to, then I flip it back over, put the tape back where it needs to be so it doesn't move. Then I make sure that this is right here. Then I put my finger on this part of the bullseye compass so that I can move it back and forth like so. And it's not moving around. It's really, really important that this does not move around on the paper and that this does not slide. That's why I told you, hey, make sure you're pressing down pretty hard with your left finger here. And then with your right finger, you see, make sure it covers both parts of this line. Then you take your pencil. And look, it works out fine. So the next thing you're gonna do, you make 2 new points where that went through. Let's call these D and E. They called them different in the book, but that's fine. So once you've drawn that, go back and look at the other part of the video if you need help looking at it again. D and E, you try to line this up with right in the center of that. And you don't actually need to move this again. You can make it shorter if you want or longer if you want. It actually doesn't matter. But since I already have it there, I'm gonna keep it there. I just want, because basically what you're trying to do is, if there was the angle that's bisecting it, get this so it would be somewhere in between there. So I go here and then put that pencil in there. And then if I did it from D, guess what? I'm also going to do it from E. So I put that where E is. There it is, and guess what I do now? This is where they crossed over each other. So I take the straight edge part of this, line it up here and here. And let's call this F. So B, F, well actually it's a ray because a ray is something, if I would have kept it as a line segment, then it would have had no extending point or array. But now I have this extra part, so it's called a ray. When you have one point and the other one is a line that's continuing out. BF bisects angle ABC. Make sense? Alright, so on example 1, try to draw that same angle. So put your piece of paper over that. I'm gonna draw it, I want you to try to draw it at the same time. I'll talk through while I'm doing it. So this is on page 73. So I'm gonna get page 73, I'm gonna try and line it up so I can draw it on there. So this is, those are different lines. And I take the straight edge part. So again, I want you, if you're watching this video, pause it, make sure you're doing this the right way, and try to do it, and then come back and watch me as I do it. Alright, so again, I start right here, make sure that lines up, and I just need to make sure that this is gonna go across where the quote-unquote angle bisector will end up, so it just needs to go over this midsection here. It doesn't need to go all the way across, it needs to go all the way across to this one. So just like here, this went, DE went all the way over here, this is gonna have to go to both of those. And right here, it could line up dot to dot, but remember that it's the same angle no matter what, so you don't need to put, it's not like you need to say, oh man, this is like slightly off from where that is. You can put it in wherever it is, so you can probably do the same angle measure. So hopefully this piece of tape you won't need to move for most of your lesson today. Whoops. Okay, so there I messed up a little bit, I gotta rearrange. You might not be able to see all of this because the camera angle's just not working out. Okay, so I ended up going out a little bit further than that, but that's fine, as long as it goes to both parts of that. And then remember, so I do this, then I have to take that same thing and I move it out, make sure it at least goes over wherever that bisecting part's gonna go, somewhere in here. I gotta move it down again. I move over to this section. Do it again. And you wanna look at where does the arcs that you drew from here, so an arc is a part of a circle. If you drew it all the way around, it'd be a full circle, an arc is just a part of a circle. That part and that part, where do they intersect with each other? And right here's where they intersect. So again, I line this up to that. And let's say I call this, I don't know, they said this was A, B, C before, I'll call this F, or I could call it E or whatever I want. But here I say BF, ray BF, bisects, angle ABC. Now they're not getting very creative with how they're doing that there, but either way it's bisecting, it's the same thing. I am not gonna have you do guided practice number 1 in the next one, because I don't think it's that much more of a benefit. But if this is confusing you, then I would say go ahead and practice guided practice number 1 as well. Any help you need with that one? Did you get it?
Yeah.
Okay. If you can get it down, I felt like I kinda went over it in good detail, then it makes a lot of sense and it doesn't, like, you don't need, like, once you got it, you're like, okay. You'll need a couple practice problems, but that's what the assignment's for. So guided practice on example 2 on page 74. Talks about, basically it's like, hey, I'm gonna show this up here. So he's like, hey, I've got this fence on my yard, and I want to basically cut it halfway across. So see what he does here, he draws that line, and then from there, he could draw that line, and that is going to bisect, basically it's bisecting this angle. It's not necessarily cutting the triangle in half, because this looks like it's probably a triangle where not all sides are equal. What kind of triangle is that?
Isosceles.
Nope, isosceles has 2 S's in it, 2 S's means 2 sides are the same.
Two are the same.
I don't think 2 are the same here, I think this is none of them are the same. I would guess,
Looking at it,
this is a scaling triangle, I think, I don't think it actually says, but I think this would be a scaling triangle. So the goal of this is not to cut the triangle in 2, but to cut this angle in 2. So that's basically what this is explaining, is a real world problem. If you were like, hey, I really want to bisect my angle, now, if you were bisecting it in person, you wouldn't use a compass or a bullseye compass that was this big, because let's face it, the bullseye compass is not going to work for something that big. So there are people, shoot, I'm forgetting what they're called, but they, no, not architect. I mean, architects would use stuff like this for sure. Shoot, I should know this. Yeah, it's someone's job where they actually use things like this. It uses it in different ways, but they definitely use these things. It's like when they're making maps or like doing things in real life.
A sextant?
I don't think so. No, a sextant I think is for compasses on a ship and stuff. It would still use something similar. I'm forgetting. It'll come to me at some point. I competed in a competition where it was doing geometry like stuff like this in high school, and like they taught us all about like, hey, here's how this would work if you did this in real life, and it was like really good. Like it was cool for us because it was a fun math competition. It was really cool for them because they're like, hey, this is what we actually do in our day to day. So it's basically saying, hey, that's how you would use that. Right here, 2 walls, they have this right angle right here. Basically this is a 90-degree wall. And it's showing like you would do the same thing, make that 40, you would make this big one, and then, see, they make really little arcs right here. You can make it work with a little arc, but you can't make it work if you don't make it big enough. and if you don't make it big enough, then it's not gonna work at all, so that's why I always make mine quite a bit bigger than it needs to. You just don't wanna make sure whatever it is with your arc, you wanna make sure you get over halfway across. So, like, right here, when I'm making my arc here, okay, I'm like, alright, well, did I need to go this far? Definitely not. I could have done this little section, this little section, this little section, and this little section. This one probably need to go a little bit further, because it looks like it's the angle type that it needs it's harder for it to bisect. This one, if it's really small, if it's a really small angle, it's not gonna be hard to create a bisector, because you're gonna be able to have a better idea of what that middle section is gonna look like. The bigger one's a little bit harder. But I'm not gonna have you redo that either. And example 3 is a similar thing. I'm not gonna have you go through that either. So I'm just gonna start you on the assignment at this point. If you need help, go back and look at these, go back at the video and look what I did for those first two either. You're gonna do it the exact same way no matter what. If it's a big angle or a small angle, you do it the exact same way. First step is, just to review one more time, I'll draw any angle here. What do you want, a bigger or smaller?
Small.
Okay, so let's make a really small angle. And first step is I'm going to draw a dot right there so I can line it up. Okay, then I do the same thing. I'm going to make these dots right here on either side of it. Then I go over, hey, I'm just trying to cross over that halfway point. Trying to cross over that halfway point. This is where it goes, see how it's like not really clear here? That's where I would probably go back and say, hey, I want this to be super clear. So now I do know I hit the right spot. And then you draw it through that. That's your angle bisector. And this is like exact precise. It's not eyeballing it or any of those other things. That's one of the incredible things about a compass. I mean, especially about a bullseye compass, because I can even line this up and say, hey, I know that that original angle was probably, I don't know, a little less than 30 degrees, so like 28 degrees, maybe 25 degrees. And this new one, it's about 10 degrees. So maybe that other one was closer to 20 degrees. This is not like the best version of compass. I have bigger compasses that I can share with you. Like this, if you wanna see what one, oh, is that the wrong side? No, that's right. So you can kinda line it up and be like, this right here, with that right there. And I can say, and, alright, so it is less than 20. Looks like it's about 15 degrees, and the other one is about 7.5. So this one's probably a little bit bigger if you're trying to figure out difference. I'll give you one of those as well. You can just ask me for one if you're watching this on video, and that's how it works. You're good to go for the assignment.